Hello everyone, welcome to Math Tired Club. I hope you're doing well. Don't forget to subscribe, comment, and like if you find the videos useful. In this episode, in today's lesson, I'm going to talk about graphing sine or cosine function with a phase shift, okay? There are going to be two videos related to this lesson. In the first video, I'm going to teach you how to graph it very, very simply with a few information that you need to know and with like a few formulas and everything. It's going to be super duper easy. But then in my next video, I'm going to teach you how to graph it using translation and transformation. The next video is totally recommended because by the next video, you can go into the depth of the lesson and you can actually understand what's happening when the normal sine is y is equal to sine x, which is a parent function, is gonna be like changing, like moving vertically upwards, downwards, or horizontally left or right, or being vertically stretched or compressed, or all these things. So the next video is really recommended to the people who want to go into the depth of the lesson and they want to understand more, and of course the people who want to learn how to graph them using translation and transformation. So the first thing I'm going to start with is the basic formula for a function, sine or cosine function, with a phase shift that is presented in this form. By f, I mean sine or cosine. A presents the amplitude, and the amplitude is related to how high the y's are going to be, how the function is going to go on the y-axis. And then the B is actually presenting the horizontal stretch or compression. C is going to present the phase shift, the movement of the graph to the left or right. And D presents the midline. And I'm going to talk about what the midline is exactly. And of course, if I want to also relate it to translation and transformation, D is related to vertical movement of the graph upwards or downwards. So let's start with an example. My first example is going to be y is equal to 2 sine 2x plus pi over 2 minus 3. That's going to be my first example. The amplitude here is going to be the absolute value of A, which is 2. So the amplitude is presented by the absolute value of A, which is 2. Remember that I told you the amplitude is related to how high on the y-axis the graph is going to go. So pay attention when there is like this number over here, -3, like the vertical translation and transformation, the graph moving upwards or downwards. A does not directly present that, okay? It is also gonna depend on what the D part is. You're gonna understand this more when I graph it. So after this, we're gonna go for the period. The period's formula is 2 pi over b, because sine and cosine function, the cycle of sine or cosine function is going to appear every 2 pi unit. It means that the cycle, which is going to look like this, for example, the sine function, appears every 2 pi units. So the first full cycle is going to appear at 4 pi, and the next one is going to appear at 6 pi, looking like this. So it doesn't matter whether the function is sine or cosine, the formula for the period is 2 pi over b, which in this case, in order to know what b is, I need to actually factor out what's getting multiplied by x and write the function in this form. So look, I'm going to rewrite the same function in this form. I'm going to factor out the 2. So it's going to be x plus pi over 4, close the parentheses, minus 3. So the b here is going to be 2. So the amplitude, the period of the function is going to be 2 pi over 2, which is going to be pi. Pi here means one full cycle of the function is going to happen every pi unit, okay? So after the period, the phase shift, if the question asks you to write that, is going to be pi over 4, okay? So the phase shift is going to be pi over 4, meaning the graph is going to get shifted pi over 4 units to the left, okay? This translation and transformation is information is going to be completely explained in the next video as well. But if the question just wants you to tell what the phase shift is, it's just pi over 4. Then we have the midline, which I'm going to tell you what exactly is. The midline is always going to be y is equal to d. And d here in this example is y is equal to -3. So that's going to be what the midline is in this example. So the period was pi, the amplitude was 2, and the midline was -3. So what do I mean by the midline? Pay attention. So if we have like the graph of sine or cosine function looking like this, this is going to be the y-axis, this is going to be the x-axis, of course, and this is going to be the y-axis. So the graph of sine is going to look something like this. What is this line? It's y is equal to 0, okay? So the midline is the line that the sine function is gonna be on exactly how it is on y is equal to 0. For example, over here, when the midline is -3, it means that the graph is gonna look like this at -3. See? So it's like this line over here, y is equal to 0, is kind of like shifted 3 units down, okay? So that's the meaning of what midline is, which in here is going to be -3. So after finding the midline, let's talk about the range. The range of these functions, the minimum of the range, and by the range we mean how high on the y-axis the graph is going to go and how low on the y-axis the graph is going to go, the minimum and the maximum of that. The minimum is going to be presented by d minus a, and the maximum is going to be presented by d plus a. So as you see, the range and how high the graph is going to be on the y-axis is not just related to a, it's also related to this vertical shift of the graph, upwards or downwards. So basically it's like the range of the function is going to be from d minus a to d plus a. That's going to be the range of the function, which in this example is going to be the d that we have is -3. So the minimum, let's find the minimum. -3, what's the a? The a is 2. Guys, this is the function, the original form of the function. I'm gonna box it so that we can see exactly what we're dealing with. Let me get rid of these so that we can see everything clearly. Okay, so the d is -3, okay, and the a is +2, so +2. So it's going to be -3 minus 2 because the absolute value of 2 is 2. So it's going to be that. So that's going to be -5. So the minimum is going to be -5. And over here, again, the d is -3. That's what I mean by the d, right? And then plus a, which is +2, it's going to be -1. So the range of the function is going to be from -5 to -1. It means the minimum is going to be -5 and the maximum is going to be -1. So after this part, I'm going to go and find the angles that I need for this graph to be actually precisely graphed on the x and on the y-axis. In order to find those angles, and by those angles I mean these angles in the four quadrants, which we know precisely what their sine or cosine is. In order to get these angles, I mean the maximum, minimum, and the other points of the graph where sine is, these points, okay? You have to divide whatever the period is by 4 to get these 4 angles in the 4 quadrants. And by 4 angles in the 4 quadrants, I mean these. Okay? So if I divide pi into 4, this is going to be the amount that I need to add to each angle to get the next one. And it's going to be these angles in the 4 quadrants when I substitute it into the equation. So let's see what I mean. This part is a little bit critical for some students, so pay attention very, very carefully. So the first angle that I want to start my cycle with, so that my graph is going to start from 0, is going to be whatever is inside this parentheses is equal to 0. So it doesn't matter whether you use this form of it or this form of it. So x plus pi over 4 is equal to 0. So x is negative pi over 4. So the first angle that I need to start with so that I can have this point of the unit circle, which is angle 0, is negative pi over 4. So the point is negative pi over 4. And I'm going to show you why would this one give me the angle 0. Look, if I substitute negative pi over 4 for x into the equation, let's see what's going to happen. See? So y is equal to 2 sine 2. The x that I'm going to substitute is negative pi over 4 plus pi over 4 and then minus 3. Negative pi over 4 plus pi over 4 is going to be 0, and 2 times 0 is 0. See? So you're actually finding 2 sine of 0 minus 3. Do you see that? I got the first angle in these 4 quadrants, 0. So that's going to be the first one. The next one, I'm going to write these as points because I'm supposed to write their y coordinate as well. So the next one is going to be whatever the first angle is, which is negative pi over 4 plus the units that I've already found in order to get the next one. Negative pi over 4 plus pi over 4 is going to be 0. So my next angle is going to be 0. So 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4. And then 2 pi over 4 plus pi over 4 is 3 pi over 4. And then 3 pi over 4 plus pi over 4 is 4 pi over 4, which is pi. And I'm going to continue until I get the first period of the function, a whole cycle of the function, okay? So pay attention. Over here, all these points are the points that are going to give me these angles in the 4 quadrants of the unit circle. So I don't need to do substitution, but I'm going to show you what the substitution process is so that you will understand it like in a better way. So y is equal to the first point that I'm going to substitute is negative pi over 4. You don't need to do the substitution every time. After a while, you can just go with the unit circle and find it. But I'm just going to do it so that you would know what exactly we are doing here and what do we mean by these angles in the 4 quadrants. Let's see what exactly that means. So 2 sine, I'm substituting negative pi over 4 again. 2 times negative pi over 4 plus pi over 4 minus 3. Okay, let me move this a little bit to the right. Okay. So this part is going to be 0, and 2 times 0 is going to be 0. So it's going to be actually 2 times sine of 0 minus 3. Sine of 0 here is going to be 0. So 2 times 0 is 0, and 0 minus 3 is negative 3. So this point is negative pi over 4 and negative 3. The next one, I'm going to substitute a few so that you would see what exactly I mean. So the next one is going to be 0.0. So it's going to be 2 sine 2 0 plus pi over 4 minus 3. I'm going to tell you before I write it that the next point is supposed to be this one on here on the unit circle. So let's see if it's exactly going to be that. And the one after that is supposed to give me this. And the one after that is supposed to give me this. So let's check it out. 0 plus pi over 4 is going to be pi over 4. And 2 times pi over 4 is going to be pi over 2. So, and this is, guys, pi over 2. So it's actually going to be 2 sine of pi over 2 minus 3. Sine of pi over 2 here is going to be 1. So it's going to be 2 times 1 minus 3, which is going to be 2 minus 3, which is negative 1. So this one's going to be negative 1. So do you understand what's happening? I'm going to calculate the next one as well for you to see that it's going to present this. But afterwards, I'm going to teach you a way that without any substitution, you can go forward with this. So the next one is pi over 4. So it's going to be y is equal to 2 sine 2 pi over 4 plus pi over 4 and then minus 3. So it's going to be y is equal to 2 sine 2. It's going to be 2 pi over 4, which is actually pi over 2 minus 3. This 2 and this 2 by. So as you see, as I said, it's going to present this other one I told you before. So sine of pi is 0. So 2 times 0 minus 3 is going to be negative 3. And from here on, I'm going to tell you that you don't need to do this every time. Okay, you have to just start with your first angle and go forward with it. So the next angle is going to be this one. What's the sign of this? Negative 1. So you don't need to calculate this part as again. So it's going to be 2 times negative 1, because sine of this whole thing is going to be negative 1 minus 3, which is going to be negative 2 minus 3, which is negative 5. So the next point is going to be negative 5. And the one after this point is going to be 2 pi again. And the sign of 2 pi is going to be 0. So it's going to be 2 times 0 minus 3, which is going to be negative 3. And then after that, it's going to be this one on the top. So it's going to be y is equal to 2 minus 3, which is going to be negative 1, which is our maximum. So you can do this whole thing mentally. So I'm going to minimize this a little bit. To be able to graph this, maybe I'm going to move it to here. And then I'm going to have the lines and everything. So most of the y's I'm having are negative. They're all negative. So let's do it as precise as we can. So we have negative 1, the maximum is negative 1, and the minimum is negative 5. So I'm going to go with this. And the points are negative pi over 4. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, let's go. Negative pi over 4, 0, pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4, which is pi. Okay, I'm gonna go with graphing it. So the first point is negative pi over 4 and negative 3, which is here. Bear with me. The next one is 0 and negative 1, which is here. The next one is pi over 4 and negative 3, which is here. And then we have 2 pi over 4 and negative 5, which is here. And then we have 3 pi over 4 and negative 3, which is here. And that's one full cycle. And I'm going to have the next one too. Didn't need to calculate the next one. So I'm going to go with the midline too, and I'm going to show you. You can guess where the midline is here. So I'm going to have that. The midline is going to be y is equal to negative 3, which, as you can see, is supposed to be over here. Okay, so the graph is going to look like this. One cycle of the graph is gonna look, that looks a little bit odd, but let's do it again. So one cycle of the graph is gonna look like this. And as you see, it's like the graph was shifted 3 units down, and the midline, that's what the midline is going to present. Exactly y is equal to 0. It's like you have shifted it 3 units down. So like this, very, very easily you can graph this function, and you don't need to worry about anything. Just with all these information that I gave you, you can do it. Guys, I hope that you have enjoyed this lesson. This lesson is very, very easy. Please watch the next video. The next video is gonna help you understand more and more about this lesson, and you can actually go into the depth of the lesson. It is very, very important for you to go into the depth of the lessons so that you will learn and understand more. I wish you all a great, great day. Don't forget to like, subscribe, and comment. See you in the next video. Bye.